Thanks, Sylvia, and hi, everyone. Appreciate you spending some time with us today. Before we begin, you should see a poll question on your screen. It would be great to learn if you and your team are currently shifting the security and compliance of your cloud infrastructure left in the security development or the software development lifecycle. Joining me to walk us through a demonstration of how to shift left on cloud infrastructure is two of my colleagues, Josh Stella and Ricardo Green. Josh is a co-founder and CTO here at Fugue. Previously, he was a principal solutions architect at Amazon Web Services, where he supported customers in the area of national security. He'll talk a bit about shift left and why it's critical to include cloud infrastructure in that process. Ricardo is a cloud technology evangelist and senior solutions architect here at Fugue. Previously, Ricardo worked at a major telecommunications company where he supported the company's managed service offerings on AWS. And he's racked up a pile of AWS certifications to show for it. He'll walk through a live demonstration of using Fugue alongside AWS CodePipeline and Terraform to help developers find and fix infrastructure policy issues early and quickly. And we'll share some tips on getting started and how to build stakeholder buy-in. I'll be back a little bit later to handle the Q&A. So with that, I'm going to throw it over to Josh. Take it away.
Thank you, Drew, and thank you everyone who's joined us today for this webinar. We're going to go through a number of things today. We're going to first talk about what shifting left is and why it's important and how it must include cloud security, infrastructure security and compliance. We're going to demonstrate, and we're also going to walk you through some tips on how exactly to do it. So to start, what is shifting left? Shifting left is an approach to software testing, among other things, but we're going to be focused on testing today, in which that testing is performed earlier in the software development lifecycle, or SDLC. And I'm just going to refer to that as the SDLC from now on. So today, what we're focused on is applying that shift left approach to cloud infrastructure security and compliance. A number of months ago, we at Fugue did a survey of 300 organizations who are operating at scale on the cloud. And this slide and a few more are going to show results from that survey. So these are 300 different, or a lot of assets in the cloud and a lot of experience living with cloud infrastructure and policy. And what we found is almost everyone was concerned about this problem. Is their infrastructure configured correctly, not just at deployment time, but the entire way through the life cycle? How do you get developers building things and DevOps teams building things in a secure way? And the reason this is such a big issue is that, as Gartner has pointed out, the vast majority of intrusions on cloud are due to misconfigured cloud resources, something north of 90%. So this question was, what are the most common types of cloud infrastructure policy violations? Over on the left, you see identity and access management. Are the right policies being applied to IAM roles and things like that? Next in line, security group rules, which, if you're not familiar, are a lot like firewall rules. So do I have the right ports and protocols open? And more importantly, the wrong ones, the insecure ones, closed, over half. Object storage access policies, about half. So these would be things like S3 buckets. I'm sure you've seen headlines about data being leaked because an S3 bucket was inadvertently left too insecure, either public or unencrypted. And then finally, the fourth big one was encryption. And this says encryption in transit. But as you know, if you've used the cloud, there are tons of places in all these cloud services where you can turn on, or you should turn on, encryption, both in transit and at rest. So we asked, what's causing this cloud misconfiguration? 64% said human error, but I'd like to point out that the other two categories here are both forms of quote unquote human error. I think this is a little bit wrong. I think this shows that we don't have adequate tooling. So when you look at that lack of team awareness of security and policies, as Drew mentioned, I come from a mix of a technology company and national security background. So I always had to deal with things like NIST 800 rules or CIS benchmark rules. Well, these are long lists of rules. I was always aware that they existed, but NIST 800-53, for example, is almost 2,000 controls in it. And so that's like memorizing a phone book. So that's an unreasonable thing to ask people to do. You can be aware that there's policy, but these policies get large and complex. So lack of team awareness is really about how we're presenting this information. And we're going to show you today how that can be done in a very developer-friendly and ops-friendly way. And then the last one, lack of adequate control and oversight. This one is kind of at odds with going fast and being innovative. And we'll talk more about that. But so our goal has to be to go at the speed of cloud, to be able to innovate and drive change and growth really quickly and build new stuff, take advantage of new cloud services and new architectures, while that control and oversight is an automated feature of building stuff and operating infrastructure on cloud. So a pretty typical response to this set of problems is to start restricting access. And restricting access restricts innovation. So if you go to a manual certification and approval cycle, if you only are allowed to run certain approved infrastructure as code templates and not change them, locking down the cloud consoles, creating provisioning guardrails. You know, when I'm learning new cloud services or experimenting with new architecture, recently Fugue did a ton of work using lambdas and step functions. I'm going to spend a lot of time making changes, experimenting with things. Having access to the console is important for things like X-ray and many other things. So it's really bad to take that away from your developers because you're going to slow the organization down. It's very kind of developer unfriendly. And then provisioning guardrails typically are implemented as something like, once systems are deployed, there is a script, maybe a Lambda script, maybe it's called a bot, something that goes and looks for things that security thinks are bad. For example, an open S3 bucket. And often these guardrails will just delete things that they find that they think are bad. This is a problem for a couple of reasons. One, it is impossible to write a script that always understands context. So if you're building a public-facing website, an open S3 bucket is a good thing. So that's one problem. Now you have to, again, you lack that context, and that script might make bad decisions for you. The other reason this is bad is the developer or the DevOps folks who deployed that, this becomes a very kind of mysterious form of behavior, right? I've done a deployment. It all went well. My Terraform, apply seemed to go fine, but now some of my infrastructure is gone or reconfigured in a way that I was not told about till after the fact. So we don't like any of these approaches, but we think, in fact, you can have better security and policy conformance all the way through the life cycle by shifting left. And that's really the alternative that empowers developers to move fast and securely and empowers the organization with its policies to manifest those policies in a way that doesn't get in the way of that innovation and progress. So we're going to switch here in a sec to a demonstration of shifting left. Ricardo is going to take over in just a second. But I want to describe a little bit what you're seeing here on this diagram as to what we mean with this and what you're going to see in the demo. So here we're using Terraform and CodePipeline to do deployment. So part of our deployment is our infrastructure as code in the form of that Terraform template. When we get to the CI/CD job, there's a new set of kind of questions being asked here. We call them validations. So these questions are, do this collection of infrastructure meet policy? If not, and we have a validation fail, we're going to return an error. And depending on whether you are going to development or QA or production, you might make different choices about what that error will yield. In development, I would argue that should just come back to the developer. Go ahead and do the deploy into dev, but send the error back in a way a developer is comfortable with and used to. So these errors are much like compiler errors when you're writing code, but these are security errors. Once you get to QA, and certainly in production, you probably want that to be a build fail. You probably want to not make that infrastructure that contains those policy violations. And Ricardo is going to demonstrate this exact process live for you. Then I'm going to demonstrate, talk a little more about the SDLC and demonstrate how these same validations can be used post-deployment. So Ricardo, why don't I hand it over to you?
Perfect. So what we're looking at right now is CodePipeline. So in typical developer go fast fashion, I kicked off the pipeline when Josh started talking. So we're kind of flowing through it, but I will talk through the different stages of how we set this up from an infrastructure perspective. As you can see, we are actually down to the Fugue environment create stage, and this is really a stage that you would add after you deploy your infrastructure that's actually going to give you that actionable feedback, which we'll view a bit later. But let's go into the different stages of it. So you're always going to start with your repository. In this case, since we are using AWS tools, we're just using code commit, which contains our Terraform files as well as our build scripts to actually perform those functions. So we've chosen to use code build for a lot of the build jobs. Other services like GitLab or Travis, you call them workers, runners, different terminology, really the same concept. So all of these things could be applied regardless of the CI/CD toolchain that you decide to use. But we dig into this. So we look at a little bit of the details of the build. So in this, in the build section, what we're doing is we're really setting up. So we're going to initialize our repository. And those of you that have used Terraform before will see this, but similar step would be taken with CloudFormation or any other tool. But this is going to give us a plan of exactly what's going to be building out. As you can see, this is a pretty extensive Terraform plan. So there's probably about 50 or so resources that we're adding to our environment that we're building out. All of those together, we're using modules, so we're pulling from different places, but to build out this complete environment. So as you can see, we get all of this feedback directly into it, and this is automated, and we'll advance. Once we exit out of that successfully, it will advance. If we have syntax errors in our Terraform plan in any way, it will fail. We'll get that feedback and be able to move on. But you can see we have a succeeded build there. And then we move on to the actual infrastructure build. So we're having Terraform handle that. That is going to simply be a job within code build. So we're having simply running some simple commands, Terraform apply, and then we're going there. Once we run the apply, now we're going to see all of the infrastructure that's being built out. So we get information regarding the different IDs, all of those details that we're building out. So probably something very similar to what you're doing in your own environments, but we get details of our security groups, but nobody's checking that. So there's no way to compile and check those against all of our security policies and compliance checks as well. And that's why we have that final stage. So that final stage is our Fugue stage, where we're actually running the different checks. So we're creating the Fugue environments. We're also going to be able to scan those environments to get that actionable feedback, which is going to be in the form of what security groups do not meet the certain compliance policies, or what VPCs are not compliant. So we're going to get all of that feedback. And Josh, I'm not going to hold us up by staring at this, but we'll see once this Fugue environment completes, we'll jump into the Fugue console to take a look at that, but also be able to see that from the standpoint of the developer that would get a report back in JSON format that will give us those details of the resource IDs that are out of compliance. So with that, I will turn it back over to you, and we'll resume later.
Great, thank you, Ricardo. Let me go back to my sharing. So this, again, is a diagram of what Ricardo just walked you through. It is now in the process of doing that checking for validations. So while that's going on, let's take a look in a little more depth at what we mean by the software development lifecycle, the SDLC. You're probably familiar with this if you're here on this webinar, but I'm just going to review it. So the basic concept behind the SDLC is a given project. Typically, this is done in Agile in the form of sprints. Go through stages, go through steps until they're deployed, and then at the end will be reviewed. We're showing this in a linear fashion. In real life, it's a loop that keeps iterating. You keep doing more of these. And from the left, you go from some description of requirements, some notion of what you're trying to accomplish, what your goal is, through to how you're going to do it, which is the design phase, and that might not be graphic design. It probably isn't. That's more in develop phase. This is really the design of the system. What services are we going to use? Where are we going to persist our data? But this is in the form of human decisions being made. Then you start building stuff. And as you build it, you're going to go through typically at least 2, often 3 kinds of testing, like unit testing, integration testing, end-to-end testing, regression testing. And then the system gets deployed. Then the application or whatever you're building gets deployed. And once it's deployed, you're going to review and decide how successful it was, and if you want to make changes, and the process begins again. So why do we want to shift left on security and compliance? Because the further right you go, the more time and money you've spent. So for example, change in the requirements and design phase, where things are easier, faster, and less expensive, it's better to make changes there than after you've already done development, because now that change, that security or compliance policy change might send you back around the horn to design and development, which is going to cost you money and slow down your efforts. So for the purpose of the rest of this webinar, we're going to take a simplified and slightly tweaked version of the SDLC. We're just going to talk about development through deployment, and then we've added monitor at the end, because when you're talking about security and compliance, you want that all the way through. You want it during development, you want it in test, you certainly need it in deployment, but then once it's deployed, you have to constantly continue to make sure that it's correct, because infrastructure drift does happen. So right now, in the current state of typical workflows, most of your security and compliance, if not all of it, happens way over to the right. They usually are checks that happen after folks have done a lot of work. And it's usually implemented as a form of gating function somewhere in test and deploy, where a team looks at things and gives approvals or certifications. Very often this is quite manual and therefore takes time. So one of the things we didn't talk about is how much time and money gets spent performing the security approval and certification function. We talked about how its results might yield rework, but it itself is often a very time-consuming and heavy lift kind of operation. And then once you're in deployment in the monitoring area, it usually, if you have any security automation, or even if you don't, it's almost always a reactionary function. So what we mean by that is, rather than having a consistent way of viewing security through the entire SDLC, developers might be interpreting policy one way, it gets deployed, and then the monitoring function gets turned on. I mentioned the example earlier of scripts or so-called bots that will look around in the infrastructure once it's deployed for things like open S3 buckets and might in fact remove them. That can be really bad. That can cause a lot of problems, but it's all reactionary. None of it's baked into the process. And in addition to those issues of cost and reactionary security monitoring, the feedback loop to the developers is really bad. Developers like to get feedback. I'm a developer. I've been a developer for decades. I like my feedback to be automated and come from my tools. If I'm learning a new programming language, I want my compiler or my REPL to tell me when I make an error so I can quickly correct it. What you get typically with the security implementation that we see out there in the industry is it doesn't work through developer tools. Instead, you get an email or a Slack notification, or even get tapped on the shoulder by somebody to say, hey, you misconfigured a security group. So this is a bad way to get feedback to developers. And this approach, kind of through bad tooling, creates a sort of intrinsic conflict between these teams. So the DevOps teams and developers have pressure to go fast, to innovate, to deploy frequently. And the security and compliance teams want to make sure that everything that's happening is correct, and they need to take a look at it. And so that, because the tooling isn't adequate without shifting left, this creates conflict between these teams. So our goal then is to integrate policy checks earlier in the SDLC to save time, money, move faster, and to be more secure and compliant. If you bake in security early, it's going to be more secure. And by using the same sets of tools for policy and compliance and security throughout the SDLC, this puts all parties on the same page and establishes the ability to have trust and collaboration between teams instead of conflict. So a little on what shift left doesn't mean. It doesn't mean shifting security and compliance from the right to the left. It means adding it to the left. So it also doesn't mean just moving that manual gating function earlier, right? Earlier in this process is when lots of iteration is taking place. So what we don't want to do is burden developers with things like guardrails on their development accounts or even audits too early in the process. So we're not talking about either of those things. The reason is we still need to do what we've been doing. We still need that checking in the deploy stage, although with good tooling, that's much easier to do because it can be largely automated, and because we've shifted left, getting things right to policy, there shouldn't be a whole lot to approve. That should have been handled in the process. But we do still need to do monitoring and remediating, fixing things, reporting and auditing. Those don't go away. But what we can do is empower developers to validate their work against the same things that the security and compliance teams are going to be looking at during deployment and post-deployment. The way I think of this is like unit tests for code when you're in development mode. So for example, in Ricardo's example, he was building a really large Terraform plan. What we often see are that work gets segmented, just like any other programming work gets segmented, the infrastructure as code does. So I might be working on some IAM roles and S3 buckets and security groups that I can test while I'm in my development phase to see if those individual units of infrastructure as code are being built to policy. But you might be, if you were on my team, working on some networks and some Lambda functions and DynamoDB modules of infrastructure as code, and then these things are going to integrate together. So just like any other code, yes, you want to be checking your units, but you also need to be doing integration testing. And all this can be handled with Fugue in a very developer-friendly way. But then the same tooling, the same interpretations of policy, the same policy as code that was being used to check and develop and test can be used during deployment and monitoring. So there's no confusion between the teams. So let's take a step back and talk for a minute about what is security and compliance. No one knows with 100% certainty what a perfectly secure computing system is, software system if in fact it's possible to make one. So instead what we do is we agree upon a set of truths about what's safe and therefore what's allowed. So for example, we all know that encrypting data in transit and at rest is important. We can agree that that is part of our security posture. That's part of our compliance, therefore, when we adopt that officially. There are usually long lists of these things. Unfortunately, these long lists are usually expressed in English, which is not an executable language, in documents or worse, verbally. So you really need this single source of truth, an agreed upon set of policies expressed as code so that they can be automated, so that the developer is getting the same feedback during the unit and integration test, during dev and test, that the security team is going to go implement in the production environment and the compliance team is going to use for responding to audits and things like that. So without that single source of truth, you end up with multiple interpretations of the truth, right? If I talk to two people in English and tell them, here's my policy, it says everything must be encrypted, we might interpret those differently. We might have different domain knowledge about what may be encrypted. We might be wondering whose keys they need to be encrypted with. So when you don't have that single source of truth and trust, you really can't shift left because the developers still aren't going to know how security and compliance are going to view their work. So finally, and I touched on this, but I believe that shifting left really must live in the developer's context. As I mentioned, I'm a developer, but I've worked in a lot of high security environments. And what I've always wanted and what Fugue has built are tools that work with my developer toolchain. I don't want to go refer to a phone book of policy controls and read through those. I want an error message that tells me what I got wrong. And that means we need automated tools for checking work. Again, much like a compiler checks your work when you're writing application code. And the answer to that is policy as code validation. All right, with that, I'm going to pause and turn it back over to Ricardo to show where we've gotten with our technical demo, and then we'll go from there. Ricardo, back over to you.
Perfect. So we will jump back into the pipeline and we'll see where we left off. So when we stopped, we were going through the Fugue environment creation. So let's actually look at the details of that. Finished about 7 minutes ago. Whole process took about 15 minutes from when we deploy our infrastructure to the creation of the Fugue environment, as well as scanning and getting that actionable feedback. So what we see here is just that process. So we get our environment ID, we have a scan ID, and then we have the actionable feedback directly of the environment that we just deployed. So when Josh talks about the quick feedback from a development perspective, it's not me waiting to get an email or a notification from somebody in our operations department. I'm getting that feedback directly. So I can look at this information to see immediately that VPC flow logging should be turned on. This is a little small, and I'll also pull this up in my editor as well, because this is a report that's going to get sent. But gives me the resource ID. So I have that actionable information that I can immediately go to actually correct some of these errors so that I can bring them into compliance. What's also nice about this feature is you can visually see it as well. So jumping into the Fugue console, we see that we've created this. So this was done at 1:13 p.m. Eastern time. So we just created that. And this is done in an automated fashion. But we also get all of these details as it relates to the compliance. So I'm getting the feedback from a developer's perspective, but also from an operations or an administration perspective. Every time that one of these environments is created and somebody deploys this infrastructure, we can now produce a scan and we can produce a report, which is going to give me all of the details. So I know specifically where I've passed, where I've failed on some of these compliance checks, and we're not checking all of the resources, by the way. But I can get all this information and I'm able to view that according to the resource IDs. So these resource IDs that I just deployed I can now see where I'm not meeting compliance, where I've exposed certain things, and I'm doing this all in development. So we talk about getting this feedback early in the process. So it's not a matter of once we're going to staging or we're actually going to prod and then doing the scans there and having to backtrack. This is all in my development. So as I develop it, I'm going to be developing on compliant infrastructure, and I'll know where I need to make those corrections. Another nice thing about automating these things is you can have this information sent to S3 buckets. So you can, along with your state file, because you want to know all the information of what you just deployed, and if you need to update it, you're going to update your state file, but you have these scan results as well. So we can download the scan results and view these directly in my editor. So I have this, I can send this file around. This could be sent to my team of developers, could be sent to the administrative folks on the team, but we also have the mapping. So direct mapping of CIS rules. I believe we're also checking SOC 2 here. We have SOC 2 rules, the mapping, messaging as to exactly what the problem is. Ingress rule on port 22 should not be open. So I know that. So I can go directly back into my Terraform files, fix those, push the pipeline through again, get that scan immediately, and get that feedback directly so that I know what needs to be fixed, and so that we're operating seamlessly and really getting a lot of information that we can take action on in our infrastructure as code and being able to automate that. So I know, Josh, you were going to show some of the things, how you would do these things later in the dev cycle. So I'm going to stop sharing and allow you to go ahead and move forward with how we would actually handle some of those things in production and staging, as well as taking it to the next level and enforcing baseline. So I'm going to stop sharing and allow you to do that.
Ricardo, thank you. I'm actually going to switch from the deck to more of the Fugue console. And we talked about what Ricardo just showed you is the kind of feedback that's going to be really important early in that in the SDLC. So while you're trying out your Terraform modules and your Terraform templates, you're getting back that information early. But earlier in the presentation, we talked about this isn't just checking there. It's not good enough to just check pre-deployment. There are other things, other use cases that need to be covered. And this is where that single source of truth comes in. So I'm going to show you a few additional use cases here. If you're operating in an environment where there is policy, it is probably somebody's job to be aware of your current security policy posture. And so I've set up this Fugue environment. Oh, and by the way, everything I'm showing you via our console is also available via API. So all of this can be automated in any of these use cases. I'm just going to show you in the console. I'll actually touch on the API in a second, but mostly I'll be showing you in the console because we do a lot of nice formatting for you here. So this use case would be every morning when I come in, I just want to see how my deployed environment that I've already taken through the SDLC and is in the live production environment is doing from a compliance perspective. And so Fugue provides a lot of detail on this. Ricardo showed you some of these before. We also offer a nice automated visualization network diagram of your environments. So we can see here our VPCs with our internet gateways and our ELBs and load balancers, auto-scaling groups, all our security groups. And we also keep, and this is really important from an auditing perspective. I know auditing isn't an exciting topic, but it's one many of us live with, whether it's SOC 2 or NIST or something else. It's really important to keep everything that ever happened in that environment. So when Fugue does these scans, we collect a complete picture of the environment and we save it forever. So you can go back in time to any earlier version you would like and see how the security posture was then and also the layout and so on of the infrastructure. So in this use case, I'm really somebody who's responsible for keeping track of compliance, and I'm checking it daily. And that's really important for that pure compliance function. Security is a little different than compliance. Compliance exists in order to make things secure, but security has other concerns as well. So I'm going to show you a couple of other environments here. This one is set up with what we call a baseline. So earlier in the SDLC, we were comparing our infrastructure to our policies until we got to a posture everyone is comfortable with. Sometimes that means 100% compliant resources. Sometimes it means there are some exceptions to that rule. Very often there are some exceptions to those rules. So what Fugue has done is we've introduced this notion that's unique to Fugue of a baseline. A baseline is a complete representation of all of the cloud resources in the environment. This is page 1 of 33 for this small environment, with all of the details. So we're not just looking for security issues. We're looking at every configuration item on every cloud resource that you've asked Fugue to look at. Creating a baseline is as simple as hitting a button or hitting a single API endpoint. So again, all this can be automated. When you're doing automated deployments through CI/CD, you can tell Fugue, I just did a deployment, make a new baseline. That new baseline is what I want you to detect on. And what we're going to detect for the security team are any drifts from that baseline. So, and this comes back to that single source of truth. The baseline is the known good contract, if you will, between DevOps, security, and compliance. And what security are going to be looking for are anything that's changing that wasn't approved and they didn't know about. So we're running this hourly, and Fugue is going to look for drifts to the environment. So what is a drift? Because Fugue captures all the details, this is a single security group, and we're capturing all the details of this security group, and we're saying this is what the baseline that we all agreed upon said was the known good state of that particular security group, but somebody went in here and closed one port and opened another port. We've had a drift, we've had a change. This is also where you can see when things get added to the environment. So someone went in here and added an IAM role. So this is incredibly important for the security team post-deployment, right? We've checked for policy up front, but once we get in production, there's always drift. It's very common in my experience when I was at AWS and here at Fugue to run into people who say, no, the only way we make changes to the cloud is through the CI/CD toolchain. And I always tell them, well, leave on drift detection for a week, and 100% of the time they come back and say, I did not realize people were going in and introducing drift and modification. It probably, almost certainly, is happening in your environment. I'm going to show you one more use case, and this is how we think that kind of security posture can be done really quickly and really definitively. So as part of this environment, again, we went all the way through the SDLC with this, but we've decided that VPCs and security groups really need to be kept exactly how the baseline said they were. If you remember my example earlier of running a script or a so-called bot that goes and looks for scary stuff, you no longer have to do this because you've caught it during the baselining stage. But what you do need is remediation, automated remediation. So in addition to a baseline here, we have turned on enforcement of that baseline, and it's just checking a box. With the script approach, you're writing a separate little program for every kind of dangerous looking thing you might want to correct for. With Fugue, it's 100% code free, both on your side and on ours. It's just a native capability of the system to revert changes back to the baseline. So let me show you what I mean by this. I'm going to go into the AWS console now. I'm not in the Fugue console any longer. And I'm going to go break some infrastructure that's been baselined. So first I'm going to grab a VPC. If you're familiar with tags, you'll know that they are often used as collections for as a view to managing your cloud infrastructure. I was talking to a friend who does red teaming, he's a CISO now, and he said, yeah, whenever I was doing red teaming against cloud, the first thing I would do is delete all the tags on everything, because that causes infrastructure effectively to disappear from the management tools very often. So I've deleted all the tags on this VPC. I've kind of orphaned this VPC network. And I'm also going to go into my security groups, and I'll grab one of these, and I'm going to edit some rules. So I'm going to do two things here. One, I'm going to introduce a security hole. So I'm opening up SSH to the world. And a security scanner might catch that, but what a old school security scanner is not going to catch is when I delete the legitimate rule. So I've deleted the correct ingress rule, the one the app needs to run, and I've added a dangerous security hole. And I've taken the whole VPC that these things are associated with, and I've hidden it by removing the tags. So let's go see what Fugue is going to do with that if we have enforcement turned on. So right now, this self-healing environment is set to run every 10 minutes. But we don't want to wait 10 minutes here, and that gives me a chance to show you a little bit about our API. So this interface is a great little tool called Postman. This is not Fugue's interface, but this is a tool for interacting with APIs, particularly cloud APIs and web APIs. So down the left, though, are all the API endpoints that Fugue provides you. So I can go here and get a list of all of the different Fugue environments that I've created. I've already done that because I want to get the identifier for that self-healing environment, for that baseline enforcement environment, so I can execute another API command to go ahead and do that scan now. Oh, looks like I caught one that was already going. So let's go back over here, and we should see a little spinning beach ball here. We do. I guess donut, really. So this scan is taking place as we speak. It's going to take somewhere between 1 and 3 minutes, typically, depending on kind of how AWS is feeling at the moment. Let's go take a look at some drift events. And while I was showing you the API, Fugue has already caught these. So let's see what happened. With the VPC, we've stored in the baseline not just that everything needs to be tagged, which is what a security script or bot might think, but rather what those tags need to be. And so we have that captured in the baseline, and we see in the drifted resource, they're gone. So that's the drift event. We'll take a look at the security group. The baseline said port 3000 should be open to the internet. But in the drifted resource, that port is now closed, and port 22 is open to the internet. So again, we're not just catching the security hole, we're catching the entire configuration. And you can see what you probably now expect to see. These are the remediation events where Fugue has fixed these things. We just put them back to how they should be in the baseline. So we've replaced the tags. And in the security group, we've both added back the needed port and removed the bad port from a security perspective. So let's go back to the AWS console just to prove that in this live fire demo, I'm being forthcoming. And you can see here on this security group, the correct port is back. The SSH port is closed. Take a look at our VPC. And it has its tags back. So these are how, with baselining, with compliance, baselining, and self-healing, we at Fugue believe you can both shift left for developers and with the same sets of rules, integrate, align the teams, build trust, move fast, and have a consistent understanding of what needs to be done all the way through the process and automation all the way through the life cycle. So DevOps teams and developers can move faster because they're going to identify those errors much sooner. Security teams can protect assets by doing drift detection, by weighing in on policy, and by doing automated remediation, self-healing. And compliance teams can automate those policy checks earlier in the SDLC to gain better visibility through the whole process. So where can we start? A few places to start. Generally speaking, what we recommend is you probably already have some cloud infrastructure. So a good place to start is to take a look at that and compare it to policy. Just understand where you stand. Identify the violations. Fix the issues. And if you don't already have a collection of policies, start with the CIS benchmark. It's not perfect, but it's a great starting place, and it'll get you a long way to implementing best practices. The next thing is you want to integrate with the developer tool chains, right? You don't want to necessarily have to sit around clicking buttons and doing these things manually. You want it to be when you do a pull request, and that pull request gets into a commit and a build through CI/CD. All this should just automatically happen, and you should get the benefit of that without having to do any work. And then once you're deployed, use baselines. Establish baselines for any, I would argue, for all aspects of your cloud deployments. And for the things that are really sensitive, turn on enforcement, turn on that ability to revert to the baseline. So with that, I'm going to turn it back over to Drew, who's been keeping an eye on all your questions. Drew?
Thanks, Josh. And keep the questions coming. And if we don't get to your question, we will reach out to you individually afterwards to answer them. First up, Eric actually has two questions. So I'll go with the most recent one first. If you delete the tags for assessment, how do you restore them post-assessment?
You delete the tags for assessment. I'm not sure what's meant.
I think what he's asking is you had a baseline, then you went in and deleted the tags, and he's looking to find out how Fugue restored those tags once it recognized that they were gone.
That's a great question. So what Fugue is doing when we scan an environment, whether it's a dev environment or a production environment, doesn't matter. We're looking at every attribute of every resource, and we're building a complete model of your entire cloud infrastructure that you've asked Fugue to look at. So we keep that state information forever. And we know everything about the state of that resource when it was baseline. That's what the baseline really is. The baseline is a complete model. And when I say complete, I mean all the details, all the attributes, including all the tags. So Fugue then has that model. So when we see a drift event, we can do essentially a diff between the two and look for the delta, look for what's changed. And we always have the data already stored in the baseline to restore it to the known good state. So I hope I answered that question adequately.
Yep, and Eric's other question, going back to the shift left in the dev environment, he's asking, is there a central management portal, or as opposed to sending the logs to developers for them to fix issues?
The answer is yes, you can do both. And I think in my experience, different folks like to use different, but the different ways. But I like both. I like to be able to send the developers errors. If you don't want to do it that way, there's always the Fugue console right here, where you can see all of these environments and their state at all times, where all of those compliance checks are being tested. So in this case, we'll look for a failure. We'll look for kind of an interesting failure. No, it's a bit boring one. Let's see here.
Josh, I'll also point out that that information can be returned as a JSON object. So if there were some sort of other tool that you wanted to receive that information, that could be ingested into that as well. So it's all accessible via the API, all of this information.
That's a great point, Ricardo. So you can use our single pane of glass for all this kind of data. As Ricardo points out with the API, you can pull it into whatever else you might be using, Splunk or whatever that might be, and return it that way.
Great. Ava wants to know, can we analyze and certify our Terraform configuration files, or maybe our Terraform plans as meeting policy so developers can just go ahead and use those?
You can do some there, right? Fugue actually focuses on deployed infrastructure, but there are some open source linters out there and things like that that will try to analyze the infrastructure as code, source code up front. a couple issues with that approach. I'm not against doing that, but it's not adequate to the problem. So the first problem is if you've used, whether it's Terraform or CloudFormation or Ansible, any of these tools, parts of what those templates, those infrastructure as code resources are going to build are pointers to things that are not in those templates. So in other words, I want to deploy this into a VPC. That VPC already exists. So that VPC, or the combination of what I'm deploying into it with the VPC, might be the actual source of the policy problem. So it gets back to that integration testing point that I made earlier. So it's not a bad thing to look for stuff in infrastructure as code, source code, or plan files, but it's not adequate to actually telling you what's going to happen in deployment, because a lot of kind of the dereferencing happens at runtime, right? A lot of the connections between things don't happen until the actual changes get made. So that's one issue with that. That's one limitation of that approach, and why we haven't explicitly focused on it. There's another, often that comes along with another problem now, which is we've checked these templates, and then to the organization, these are the only templates you can use. That sounds good up front, but it's got some issues with it. The first one is you've just limited your ability for developers and DevOps folks to innovate. You've once again, you're kind of turning the cloud into a data center, in that here's the list of stuff you're allowed to pick off the shelf. Don't touch anything. That really is limiting, and especially as new cloud services come out, it's limiting often in terms of options that are available, but it also tends to create a backlog of work on some team building those centralized templates. So these things aren't necessarily bad things to do. I would argue that the limiting people to only approve templates thing is a bit too limiting, but I'm a developer and I like to be creative. I like to innovate. But it's still not going to help you really understand your security posture once those templates have run. They have to interact. They have to be fully resolved before you can know really whether or not that infrastructure meets policy. So for example, if you have a pointer to an IAM role in your deployment for some Lambda, and the IAM role is not in that template, you could end up pointing at an IAM role that doesn't meet policy post-planning once you're in deployment.
Great. Vaibhav has actually two questions. He just popped one in that I think is response to what you were saying, where he says, I see scope of static code analysis for more faster results along with compiled analysis. Did you want to comment on that, Josh?
Yeah, sure. So static analysis, so to do real static analysis requires certain features to be in the language that are fairly, I mean, we know this in programming languages. We've certainly experimented a lot with that and have a number of patents on it here at Fugue for infrastructure as code. But the popular infrastructure as code languages don't typically have, to my knowledge, none of them have the features in the language like strong type systems where you can do static analysis, right? If you're, and I don't want to geek out too far on programming languages, but it's kind of necessary to answer the question. In a dynamic language, something that only fully dereferences at runtime, you can't perform full static analysis. So you're going to have gaps in your understanding. It does get you faster feedback, and I'm a fan of that. But with things like CloudFormation, Terraform, Ansible, these are not strongly typed languages with real kind of features needed to do complete static analysis. So no harm in doing a partial approach, and I think that's why you're seeing people mostly writing linters. We've definitely experimented a ton with compiled static languages for this, but that's not what we're here to show today.
Oh, great. He also wants to know, do you see the need of access control here? The person creating the baseline and doing development can't be the same, or else baselines will keep changing as per conveyance.
Yes, so definitely. What you're going to want to do is when you use Fugue, you register API clients. Those API clients are things you can kind of hand out and integrate into, say, Jenkins. So your developer, rather than necessarily having full Fugue access to lots of environments and baselining and things like that, they're getting the downstream result of that Jenkins integration, which you can limit at the API layer. So that's possible to do right now.
Okay, great. We'll have one more question. Does Fugue work the same way with CloudFormation as it does with Terraform? Because there's some differences with regard to like the Terraform state file.
There are huge differences between Terraform, CloudFormation, Ansible, Chef, other things that do this kind of cloud configuration. And this is another reason why we focus on the early in the SDLC, the deployed environments in dev and so on, because we work with any of those tools. Or you can just go in the console for all we care, because we're operating against the real state. And we're building that complete model where we really can do not static analysis of code, but static analysis of state. We don't, post-resolution, post-dereferencing, we don't care what you use to deploy. We integrate really nicely with Terraform. We integrate just as well with CloudFormation. We tend to spend a little more energy on Terraform because it's a little more popular, but CloudFormation's fine with us too.
Okay, great. A couple questions we didn't get to. We will reach out to you and answer those personally. And Josh, you want to wrap up?
I think that's a cue that I'm supposed to go to another slide. Let's see. Yeah. So yeah, please reach out. I'd love to hear from you. If you email me, I will respond. And thank you very much for taking the time today to do this webinar with us. I've really enjoyed it. And your questions were excellent. So I'm just josh@fugue.co.
Yeah, and reach out. We would be happy to arrange for a security workshop and a free compliance audit of one of your cloud infrastructure environments. It usually takes less than an hour to complete. And you can kind of see how Fugue could work inside your workflow and environment. So thank you very much.